Welcome to Principles of Lean Manufacture for Small Manufacturers. This module provides industry insight for small manufacturers to be able to apply principles of lean manufacture to their business using advanced Business Cloud Essentials software. So why lean manufacturing? Well, any business, manufacturing or otherwise, needs to be sustainable. And to be sustainable, it must be responsive to changes of the market and wider political changes. It must be profitable. It must be solvent as far as cash flow is concerned. And to be able to grow, it needs to be scalable. It also needs to be competitive. It needs to be able to respond to pricing from market forces. It needs to be able to minimize costs, produce an offering which is of the highest quality, and service which is timely for consumers. To facilitate that competitiveness, the organisation must be efficient in terms of time, in terms of space, in terms of materials, and avoiding redundant stuff. This is where lean manufacturing provides the foundation that enables this efficiency, competitiveness, and ultimately a sustainable business. Lean manufacturing relies on principles such as just-in-time with regard to raw materials and finished goods, and also JIDICA for quality at source, which builds for the efficiency required. Lean manufacturing may be thought analogous to a house. The manufacturing organisation must have a stable basis before this can be built. Upon this, standardisation of process, of materials, can be built, sustaining the two twin pillars of just-in-time and JIDICA. Just-in-time relating to both material deliveries and purchases, and also process completion of manufacturing operations. JIDICA referring to quality at the source. This supports the goal of lean manufacturing, which is the highest quality at the lowest cost with the shortest lead time. Another way of looking at this is an approach for waste elimination, where we define waste as anything that does not add any value to the end product from the customer's perspective. So really the customer is looking for things which are value added relative to the raw product or maybe to a competitive offering. But many of the things which are necessary to produce the finished goods don't necessarily add value to it. Whether it's transportation or inventory, movement not only of goods but of people, waiting time, overproduction, overprocessing, or defects, none of these actually add value as far as the end customer is concerned. And so if it was possible to, for example, reduce the number of defects and hence the amount of waste, then we would have reduced waste and increased efficiency. Likewise, if we can avoid moving goods backwards and forwards unnecessarily, again we'll increase the efficiency. If we can avoid overproducing things that we don't need, that are just in case but ultimately are not required and may even become redundant or past their shelf life, again we increase the efficiency. Lean manufacturing brings about new thinking. For example, with regards to cost, the cost reduction principle takes traditional thinking and reverses it. So within traditional thinking, the price which a product might be sold at may be arrived at by looking at the cost of manufacturing in terms of raw materials and the process time and the operations required to produce the goods, and then deciding what profit margin or markup we would like to achieve as a business. And adding that profit onto the base cost determines the selling price. Although mathematically the same, a rather different way of thinking is to set the price not relative to the cost of the manufacturing of the raw materials, but relative to what is acceptable to the market. What is a competitive price? And sometimes that price may in fact be higher because of supply and demand, or because of the uniqueness of a product. Other times it might be lower, and in fact it might have to change to be responsive to market forces, to new entrants, and to other changes. Having started by a fixed price, then the profit which can be achieved is relative to the amount that the cost can be controlled. And so to increase the profits, then we would continually look at ways that we can reduce the cost of the operation, maybe by having greater buying power, maybe by renegotiating contracts to buy in cheaper materials, or maybe by looking at the efficiency of our manufacturing operation and looking at ways to drive down cost. Many of the themes of lean manufacturing look at reducing inventory. Why would we want to do that? How is that going to aid efficiency? Because in some ways this may be counterintuitive. Well, the danger is that with regards to raw materials entering the factory or the production, there's a danger that we might order too much, and there's an order that we might order too soon. This could lead to internal problems, such as working capital being tied up, affecting our cash flow. We can't then use that money for other things. And also to storage space being tied up in the warehouse, which can't then be used for other things. In turn, this can impact the customer because the costs are higher for the finished goods, and potentially we may miss deadlines. Likewise with finished goods, if we make too much or we make it too soon, this is going to lead to internal problems such as working capital being tied up, working space being tied up, so not just warehouse space, but dealing with a manufacturing area, which is going to make it a less safe and a less efficient environment. Or if we try to avoid that, then we might end up double handling goods, moving them from one location to another. We can have quality issues due to big batches, where we're unable to be responsive to quality issues as we would with small batches. And if we're making too much or we're making it too soon, then if these are perishable goods, then they might pass a shelf life, or they might simply become redundant. If we make 1 million blue widgets, then we're in trouble if we discover that next month the market demand is for red widgets. Again, this ultimately leads to problems for the customer in terms of potentially reduced quality of the finished goods, higher cost that we need to pass on to the customer, missed deadlines, which is going to impact the customer, or maybe less choice as far as the customer is concerned. All of these are reasons why inventory should be reduced wherever possible, both in terms of raw materials and in terms of finished goods. And lean manufacturing facilitates this. There is, of course, a point at which a batch for manufacturing could not only be too big, but it could ultimately be too small. Unfortunately, there's a simple equation which can help us to calculate what the economic batch quantity should be. So if we're making widgets, how many should we make at a time? And the equation is simply to look at the setup cost of a batch and multiply this by the annual demand, multiply it by 2, and divide it by the annual cost of holding 1 unit of finished inventory. And the square root of this sum is in fact the economic batch quantity. That batch setup cost may take a little bit of thought to ascertain what the true cost really is. So what kind of time cost is there to batch changeover? Setup cost to the machinery of the process. How does this impact the worker speed due to changes when getting out of a rhythm? Do we actually need additional resource for supervising the setup relative to the operation of a batch? And what about any wastage due to machine feeding? All of these factors build into the batch setup cost. But similarly, we have a carrying cost. So of course, there's the cost of the warehouse divided by the amount of items in it, and maybe an opportunity cost because the same space can't be used for something else. We've thought already about the danger of obsolescence of inventory, where simply we make things where they either pass a shelf life, or we simply don't manage to sell all of them before the market changes. And we must think about the cost of capital, the money which is tied up in that, either directly or indirectly, has a cost to it. And so these factors help us to feed into the equation, along with the annual demand. How many of these items do we need in a year that we're actually going to sell? And that will help us determine the most economic batch quantity to produce things in. And that may well be smaller than the batch quantity which we're making in at the moment. We talked about the twin pillars, and one of these is Judica. And essentially this refers to quality at source. Now, most commonly this is thought of in terms of a physical machine, and it may well apply to machinery, where especially in larger scale manufacturing and robotic processes, then the machine itself might be capable of automatic monitoring at a simple level. That might be weighing the items as they pass through, and if there's a discrepancy in the weight, then that can be a sign that something's not right. And with that automatic monitoring, then the principle would be to stop if it's not right, rather than continuing to do something which is essentially wrong and is going to feed into problems down the stream and be more difficult to put right. But in the context of small manufacturing and in the context of applying business software to manufacturing, then we can extend this principle to processes. So what if there's a purchasing variation? What if we would expect to purchase things at a certain price, but we notice that in a particular instance or in a particular trend that cost has gone up from what we expected it to be? What about manufacturing variances? If we anticipated that the time associated with a process was a certain amount of time, but in fact it's taking longer, or we can see from a trend that that's changed over time. Potentially we need to do the same thing as we would with a physical machine. We need to stop if it's not right, and then look at the source, whether that might be the source of the root cause of a problem, whether that's related to plant or machinery, whether it's related to staff, a training issue, or even a management or motivational issue, whether it's to do with a particular rogue supplier or a change in the materials. Once the root cause has been established, prompt action can be taken, and that can enable quality at the source and before that problem replicates itself downstream. So whilst lean manufacturing is something which has been successfully applied for decades in very large manufacturing such as car manufacturing, it very much applies to small manufacturers as well. And these principles, the first steps can be to look at things in this order. Purchase just in time. Manufacture just in time. Optimize batch size. And practice continuous improvement. Advanced Business Cloud Essentials software can help us with all of these things. So to purchase raw materials and to purchase stock for resale or stock for use in assembly of components, we can purchase it in the right time with MRP, software that facilitates materials requirements planning. And that looks at a whole array of factors such as the required delivery date of the finished goods. So it's very much driven by customer demand. So we're not stockpiling, but we're working backwards from the date where things are going to be required. We then factor in, the software is then able to calculate manufacture lead times. How long is it going to take to process and to produce things in time for delivery to the client? What about sub-assemblies? So not only might we have a manufacturing process where we manufacture finished items, but there might be sub-assemblies which in themselves need producing. And then whether it is raw materials for manufacturing or components or even goods which are shipped direct to the customer, we have to think about purchasing lead times. How long is it going to take for these goods to come from the client? With this matrix of dates and lead times, the software can then start to make recommendations as to when purchases should be made and how much to facilitate just in time. That's not always the best approach. It might be that for some organisations that some of the things which they are purchasing are of high value but relatively low volume. And in some cases, then the best thing to do might be for those to be linked to the sales order and for the purchase to be back to back. Whereas other things within the stock repertoire might be best handled on a minimum replenishment basis. So the software will advertise when things are approaching the minimum of a safe stock level and taking into account the lead time for purchasing, recommend replenishment purchases at this stage. All of these things are facilitated with different aspects of the Advanced Business Cloud Essentials software. Manufacture just in time is facilitated by the MRP process as well as suggesting what purchases should be made at what time. It can also suggest what works orders should be produced at what time. This can then feed into the job scheduling screen, which is a particularly powerful tool for looking at resource allocation to get the most out of the assets and to look at how these are being utilized and potentially to be able to drag the jobs around to change the order again so that it's more of a pull than a push, so that it's driven by customer demand, not by stockpiling. But looking for efficiencies where the setup time and the cooldown time can be overlapped, or where we can be flexible and modify the working period to allow a batch to be completed in a certain day, and where even if overtime is incurred, that might be more efficient in the long run than having things which are spanning days and spanning weekends and impacting the scheduling calendar depending on demand. Another tool which is part and parcel of the Advanced Business Cloud Essentials software is Live Process View, which again aids the lean manufacture principle of manufacturing just in time. And this can be used on the factory floor to process by resource, so by machine or by operator, and to present jobs in the right order on a production line basis, to be able to reprioritize them, to take account of an urgent order which takes precedence, and to be flexible to the market, potentially even to be able to charge a premium for this flexibility or a competitive advantage over other manufacturers, to be able to reprioritize jobs, or to be able to process by orders, to be able to follow a particular order right through the different stages, to give flexibility, having both the advantages of a production line type approach, but also an order-centric approach as the case demands. We've talked about mathematically how we might optimize batch size, but the software facilitates this against manufactured items where we have bills of materials. Then we've got the ability to determine a normal batch quantity, a minimum batch quantity, to say whether we want to use the normal batch quantity or whether we want to consolidate multiple works orders into one order. And then also the metrics which go into this. The software can actually be the tool for continuous improvement to be able to measure these things, to be able to tweak and to tune the optimum batch size by actually taking measurements using the software, because the manufacturing is very granular in the way that it enables timesheet reporting of processes, so we know more accurately how long things are actually taking as they go through the different processes. And using the reporting, we can use the accounts to ascertain what our storage costs are and to be able to allocate those correctly to factor into the calculations for optimum batch size. Business Cloud's Essential software also allows the principle of practicing continuous improvement, which is one of the tenets of lean manufacture. It does this in a number of ways. It has a dedicated module for quality assurance, which allows a log to be created of any non-conformances, and this is searchable, allowing for any repeat instances to be quickly identified and remedial action taken to avoid perpetuating bad practice. Where that feedback is coming from customers, where unfortunately goods have made it out but they've been defective, or there's been a breakdown months down the line, or where there's a guarantee with the product and the product's guaranteed, the software's even got a module for support tickets, and again this enables analysis of the kinds of support tickets and how these link to the different products, and even the batch traceability of what raw materials and everything which is going into the products, to look at the root cause of where some of these support tickets might be coming from. We can also practice continuous improvement using the Business Cloud's Essential software through powerful reporting. So, for example, the manufacturing report allows us to look at purchase price variance, differences between the anticipated costs and the actual costs at purchasing, factoring in actual wastage in the production variance report. How much time did it actually take compared to what we thought it was going to take? How much material did it take compared to what we actually thought it was going to take? And throughout the software, being able to have a principle of drillable reporting, so being able to move from the high level where we can see trends to drill right down to the detail to look at root cause, whether that relates to the plant, the machinery, the staff, the materials, the suppliers, or whatever that might be, to be able to implement change and practice continuous improvement. And it's important not only to be able to do that at year end or even month end, but to be able to see this on a dashboard type basis in real time and be able to make those changes sooner to gain a competitive advantage. And so we've seen some principles of lean manufacturing which, whilst they apply in much more detail to very large manufacturing operations, we can still take some of these basic principles and apply them. And we've also seen how the Business Cloud Essential software enables to apply some of these tenets, such as purchasing just in time, manufacturing just in time, optimizing batch size, and practicing continuous improvement. Lean manufacturing isn't an aim just for the sake of it, just to be able to say that we do it. It's to be able to build that efficiency in terms of time, space, and materials that we've talked about. To be able to then, through that efficiency, gain a competitive advantage, whether that's through a more competitive pricing strategy, being able to control the costs and the profitability, being able to reinvest profits, being able to improve quality relative to competition, and punctuality or even flexibility relative to competition. And these things are going to build into a sustainable business which is responsive, profitable, solvent, and scalable for long-term success. Thank you very much.